Okay. So we finished this last time. In 802.11 which is the IoT 802.11 for IoT, everything is shortened. They want number of bits to be less and the speed to be less so that the distance can be large, right? And the number of stations also they want large. So to increase the number of stations to 8,000, obviously you didn't want to treat all 8,000 as the same. If you use all 8,000 as the same, you need 8,000 bits in the beacon to tell, whose turn is what, right? Whose packets are waiting. So I said we cannot do that, and we will just do it for 2,000, which was the originally in the other 802.11 standard. So they broke it into 8 pages, and so then and the pages are also broken into blocks and sub-blocks and stations. And so basically, instead of treating the whole thing equally, they just put into what we call segments. And segments is different from pages. Segments is any subgroup. So we could, for example, make this as 3 segments, even if I have 1 page. Okay? And segments, you make it by making blocks and sub-blocks. And then when you contend for a slot, they might reserve a slot for you, but not just for you, but for the whole segment. That way, only 8 or 9 people will contend for that particular slot and not 8,000, like in the original standard, or 2,000 in the original standard. Okay? So that way, the efficiency goes up for a large number of stations. Is that point clear? Okay. The restricted access window is exactly that, is a slot which is reserved for a group of stations. So there are a whole set of slots, and each slot is reserved for a group. In that way, it reduces the contention. A TIM station, and TIM was that time indication map. TIM station can be allocated slots during restricted access window RA to transmit or receive the packets, right? And RA is this restricted access window. RA is a part of the contention-free period. So in 802.11, we had contention-free, which is reserved, and contention-based, right? In the original standard, contention-free was just reserved for 1 station, right? Now here it is for a group of stations. Access may be granted for transmission, reception, polling, etc. to 1 or a group of stations. A RA schedule is transmitted at the beginning of the RA interval. Okay. So whenever the RA begins, first few slots will tell you what the rest of the map is. Map means, which group for what. A station can tell access point if it has frame to transmit using an UDI indication bit. So basically, the way a station has a slot, let's say slot number 5 is yours. In that 5, you cannot transmit too much. Slot is very small, right? But you can send a small frame, and you can put the UDI bit in that one up. Once that bit is up, then the access point knows that you have something to transmit. Okay? And it will give you a better scheduling next time. So transmit using UDI bit, and dividing stations into groups and dividing times into slots for each group increases the efficiency under heavy load. And last time we had discussed that fully reserved is good for heavy load and fully random is good for light load. Okay? I mean, even for the traffic lights. When you are standing at the traffic light, if there is no traffic, you feel, why did they put the traffic light here? So if there is no traffic light is good. Randomly people come and go, right? If 5 o'clock, you cannot do random. And there is traffic, you need to reserve time. So that's what it is that dividing stations into groups and dividing the time into slots, and then each group has a smaller number of slots, gives efficiency close to 100% at 100% load. Okay? And regular EDA-CF will give you 0% at that load. Nobody will succeed. If there are 8,000 stations, you can keep, extending your collision window, and you won't succeed. Okay. Now, this is another one of those little things that, sounds so simple, but was not used in any of the protocols before. Right? So now that we have discovered it, it will be used in all of the protocols from now on. Okay, so there are not just two extremes, contention free and contention period, right? There is in between where there is contention, but only a small number of people. Any question about RA? Well, similar things are used for other things. Periodic RA, period and duration of the RA are announced. Periodic RA is for periodic stations. Sounding RA for sector sounding to figure out how many sectors you have and how many sectors I have. Remember, we did it for 802.11ad, where we figured out that you have 3 sectors and I have 4 sectors, and my third sector aligns with your 4th sector. So that is called sector sounding. AP power management RA to announce when it will be sleeping. So it will say that is restricted access during this period, I'm gone. Non-TIM RA. So the stations which are not TIM, there were 3 kinds of stations if you remember. TIM stations. Then there were stations that were periodic, and third that were totally random. Totally randoms are the one which will come up once a week or once a day or something, very rarely, right? So non-TIM, those are the last 2 categories are non-TIM. And then triggering frame RA allows stations to send PS pole frames, indicating their need to transmit. So PS pole is basically power save pole. Is that I was sleeping, now I'm up, can I send? Right, you send this to, and similarly there is another pole which is every beacon, the access point announces that I have frames for 5, 3, and 2, whatever. And then when you hear that, then you say, okay, all right, I am up. Please give me that station. They may announce 1,000 times, and after 1,000 times you hear it, right? So then you say, okay, I'm up now. Give it to me. So that's another kind of pole, PS pole. But here PS pole is used to indicate your need to transmit. You can also indicate your need to receive. Are you are up to receive? So these are all reserved periods. Basically what it is that now CFP, the contention free period, has many applications, and 5 of these are listed here. One we saw before, which was just for TIM station transmit. All right. So for the stations which are not TIM, which wake up after a day or whenever they want to wake up, they have a target wake up time. Okay. So they say, well, I might sleep for some time. Now the time could be very large. So instead of specifying the time as how many seconds are going to sleep, you specify the power, mantissa. Okay, so you specify like 3.2 times 10 raised to 15, something like that. So you specify the mantissa. So that is basically specifying in log scale plus the thing is, right? So you can specify a very large range, right? So you specify your wake up interval mantissa, and then they will not bother you for a day. I mean, whatever time you have specified, and then when your time is for you to wake up, then they will start announcing that I have a frame for you. Otherwise, there is no point in the access point announcing every second, and you are going to wake up in a day, right? So now you can sleep for long. Even the access point can sleep, and when the access point wakes up, they know when you are going to wake up. Just near your wake up time, it will start announcing that I have frame for you. And then you can send that PS pole to get that. Right? Target wake up time can be very large. So what this picture tries to show is that in 11AH, there are two stations. They have a different times to wake up. And the access point has its own time to wake up. Right? So, of course, if you're going to wake up every day and the access point is going to wake up every hour, so there will be 59 minutes when there's nothing can be done because everybody is sleeping. Right? When the access point comes up every hour, and then it says, oh yeah, this guy had said he will wake up in 24 hours. Time for him to wake up. So then it will send out the beacon and then they will do. So they will become active. So these active times, could be rare and could be somewhat consolidated around the target wake up time. Okay. Now this is going to be basically very different than Bluetooth and Zigbee and other protocols that we have seen. So I have very high hope for this. Now this is all theory right now. This is all theory because there are no products doing 11AH. Right? The standard is still on the draft 5 as I told you last time, right? But that's it. Authentication. So basically new mechanisms to allow authentication a large number of stations. So centralized authentication. Basically, if 8,000 stations are going to come up, how are we going to authenticate? So that for that they have again put people into ranges. If you are between this and that, then please come and register. And then if you are between that range, so that way we can see, right? And for authentication, of course, there is a contention. Even for let's say 0 to 1022, there is a contention. And so there is exponential back off as usual. Okay. And I would not be surprised, I'm not saying this on this slide, but that there is a trust center somewhere in the back. Trust center does not have to be in the access point. In particular, because the access point is much more open, anybody can steal the whole access point. So generally the trust center is separate, somewhere logged in a key, somewhere inside a locked door. Okay, that is where the authentication will happen. The main new stuff here is that for authentication there is a back off. And group sectorization is that access point generally could have many sectors, and each station will be told what sector they belong to, and then the stations will be told when they can transmit in each sector. Okay, so this is remember what this is called. This is called not home area network. What is it called? Anybody remembers? It's not home area network. Wide area? It's not wide area network. It's a new name. And nobody remembers it. N-word. Nobody remembers that one? What is that? Neighborhood area network. Right? So the neighborhood area network basically means that it is covering a mile of neighborhood. Right? So there could be a lot of devices, lot of meters to read that this will be used for, right? So that's why they have sectors and things like that, and so on and so forth. That brings us to the end of AH. It runs at 900 megahertz, and you know why at 900 and not at 2.4? Because 900 goes much farther, right? At least 3 times longer, if not more. And they didn't have to invent a new 5 for it. They just took 11 AC and clogged it down by 10x. What does that mean?
It means longer duration in time.
Yeah, so the time domain duration is 10 times. Frequency domain, it is 1/10. Good. So longer symbols, longer multipath. So now you can go longer distance. MAC is more efficient by eliminating or reducing the header. Header was 12 26 bytes shorter. Aggregating ACKs, you didn't have to ACK every packet. Null data packet, everybody remembers null data packet? What does that mean? 0 byte MAC layer. Everything is phi. Okay. Null data packet. Speed frame exchanges means many frames in a burst. You can just send. And you can receive and send and receive and send. So exchange. Saves energy by allowing stations and access point to sleep. Longer sleep using the target wake up time and restricted access window. Okay. So those are all the new stuff in 11AH. Yeah.
Can I ask a question about authentication? The authentication, you said that the access point announces the threshold and the beacon. What?
No, slowly. Access point is what?
Announces a threshold and the beacon.
You want me to go back to the slide?
Yes. So I was wondering how much is the threshold? Like.
Okay, numbers. Okay, hold on. Let's say I have 13 people here and I want to authenticate. I could say first 5. Okay, 6 through 10, and then 11 through 15. Threshold is simply the range.
I know, yeah. I mean, like, the huge number of stations would be like authenticated, or it's just a small group of.
No, one by one. Everyone has to be authenticated. Yeah, I can't authenticate 5 at the same time. Right? But the thing is, I don't want to authenticate 15 at the same time, so I divide into a small group and say, okay, like in the next 1 minute, let's do 5. Okay, so these guys will remain quiet. And then next minute, these, this and that, right? So just dividing them into ranges. So there is not too much contention. Otherwise, you won't get past authentication, let alone operation. Good. All right. So there are a lot of activity in this new area called LPWAN, Low Power Wide Area Network. There's a lot of activities. And these are all the things that I could find. All right. Luckily, one of them stands out so much that I had to present to this class, LoRaWAN. The reason it stands out to me is that I went to this IoT World Forum in Dubai whenever. And in December actually, yeah. And IoT World Forum, and Cisco arranged it, 2000 big, like CIOs. You name the company, GE, all the company, IBM, all their CIOs were there and everybody else. They took us on a tour showing what a smart city will look like. Dubai is the smartest city in the world. At least in that time they said that. Okay, so, and then they showed us, they took to their smart park, a new city where they're building, and they said, oh, this is LoRaWAN. And I had not heard of LoRaWAN then. So I said, okay, well, I got to figure it out. So LoRaWAN is there in the sense that it is being used, and Cisco is a member of the LoRaWAN Alliance and LoRa Alliance, and all the big companies are member of this. It's not, basically it's a mixture of both standards and proprietary thing, but it is going very fast. And it could have, there are two things that can happen in the future. It could have a future like Web HD, and that was whatever HD it was, right? And 60 gigahertz thing where it was alive in 2009, but not alive in 2015 anymore because 11 AD came in. So LoRaWAN is alive right now. Right now, if you want to experiment with any long distance thing, you have to have LoRaWAN is the only choice. Not the only choice, is the main choice. Is a good choice, okay? Whereas 11AH is not there, right? So two things can happen, that 11AH will be so late that nobody will care about it. LoRaWAN will be firmly entrenched. Or IEEE could wake up and say, look, we got to push out the standards faster than what we do. And then LoRaWAN would be gone. Okay, with that, I'm going to tell you about LoRaWAN. Long range wide area network. So it was developed by a company in France, a small company, which was bought by Sematec Corporation. And And they know that everybody knows nowadays that you cannot sell anything proprietary. So you have to have a group of company around you. So they formed the LoRa Alliance. And LoRa Alliance has 160 members. And the standard just came out in January 2015. But products are there. So I went to Amazon and you can buy an Arduino Radio Shield for LoRa. You can buy, for Raspberry Pi and so on and so forth. And in fact, I might even be experimenting with these. Because it is a long distance, much longer than 11. And it is there. You can buy it today. You can play with it today. And actually, I saw it working. So that was another big thing. To see it in a demo where we are driving and the building over there is LoRaWAN, and we could see the effect. Okay, that was very powerful. All right, so rapid adoption products are already available on Amazon, and these are very cheap, by the way. So this is something that if you want to play with, and these things are sub $100, less than $100. It is all here. Features. Bidirectional communication. So it not only that you can use it to collect the sensor information, you can also update the sensors. Okay, so if you have to do any firmware update, meter update, or whatever, it can do both ways. Of course, it is very low rate, 0.3 kilobits to 22 kilobits in Europe and 0.9 kilobits in US. Every country has a different rate because every country has a different wavelength. Every country has a different band, size of the band, bandwidth. And every country has a different rules for what you can do with that bandwidth. The topology is stars of stars. Now again that you notice that this was in 11AH. Zigbee went a bit too far with mesh, and I don't think mesh is succeeding. So they are kind of, trees of trees, we said, stars of stars. So that's what they do here, stars of stars. And so basically with one level of relays, which are optional. Now there are two pieces of information here, that there is a gateway and there is a server. Okay, it is difficult to say which one is the access point. They have a different function. So actually the function is coming in the next slide, so I will hold on to that one. But notice that this one shows a wireless, this thing, and this one doesn't have wireless. So server is somewhere in a room connected by wire. The wireless part is called gateway, and the server is the real brain, of the whole thing. And of course, the gateways can talk to all the devices, or if they need to reach some devices, they can reach through the relays. So that's how it becomes trees of trees. And security-wise, each one has a key. The key size is 128-bit for the devices, 64-bit for the network. So what is the network key? Before you can participate in a network, you need to know its secret, right? I have my certificate, I have my keys, but I can't just go and join a meeting. Let's say in the chancellor's office there is a meeting going on, right? So I need some secret to be able to get into that meeting. So that is network key. Okay, and so this is 64-bit. And 64-bit application key. So you join the network, but you can't just go and start reading or writing the electrical meter reading. You have to be part of the electrical company. So that is the application key. So this is another new concept, actually, basically, is that you just don't need one key. Right now in your home, when you program a network, you put the key, and then you are free to do everything. You can print, you can play music, you can look at the files, which was yesterday good, but not good anymore, right? One of the workers who came to my house and said, can I use your wireless? I have a problem, because if I give her access to wireless, she can see everything, right? So I have to immediately create a new wireless guest network and give her that so that she cannot access my files, but she can access the internet. Right? So now that application is allowed, but printing is probably not allowed. I don't know about printing part. Things like that. So now, the thing is now you have to have keys for everything, for every privilege that you want. Every application, network, and yourself. Right. So there are three classes of devices. Uplink transmission followed by two short-linked downlink schedule determined by the endpoint, which are simple devices. So basically, class A is that whenever you transmit, you are given, you can receive up to two things downstream. Okay? And that's it. You cannot receive any other time. When you next time you transmit, you get two more things to get down. Okay? And so the devices are very simple, and it's all pure Aloha. Now remember, LoRaWAN is before 11AH. Right? So there are some features in 11AH which are not there in LoRaWAN. So it's pure Aloha. Pure Aloha means contention, basically. You just contend. And it works okay if your load is low, and that's what they assume, that the load is low. If the load is high, then in a long time ago we did the analysis. Everybody did the analysis. Back in 1980s, it was kind of common for all the academics to do analysis of contention. And Aloha is known to have performance of 1/2E. Right? E is 2.7. So 1/2 is 18%. That is efficiency under heavy load. Gateways listen to multiple transmissions on multiple channels, and all gateways listen to all transmissions. So that's another thing. There is not one gateway. Okay, so this I should have pointed out in the previous slide, which I didn't. Maybe I will change that slide. Is that gateways could be many gateways. So I could put a gateway here in that building and that building and that building along the road, and you can talk to any gateway. Right? Gateway is not the brain. Gateway is just going to receive your thing and give it to the brain, and the brain is server. So everything will go to server, and server might even get multiple copies because multiple people listen to you and then they send it to the server. So the access point, so this is another thing, is that they divided the access point function into two functions. One is the radio function and one is the non-radio function. Right? The radio function is in the gateway and there are many copies of it. The main function is in the server, which is somewhere else. So all gateways listens to all transmitters. So there is antenna diversity by design. So you are transmitting to 4 antennas, and from your one antenna, there is already 1 to 4 streams, right? So you get that, and then whatever is the strongest transmission will have the best reception. The server will know, and then server will tell the gateway, now you are the one who is going to do the downlink one. Okay, so you won't get 5 responses back, you will get only 1 back, even though you send to everybody. And so this allows mobility. Yeah, question.
It says that 2 short downlink.
2 short downlink, yeah.
So the second one is like from another gateway, or?
Okay, so very commonly, downlink is nothing but the acknowledgement that I got it. Most commonly, okay? Now, the thing is, sometimes I do have to send you, like, for update or whatever reason, I have to send you some information, right? So that's why it doesn't say just acknowledgement. And it's not just 1, it is 2 short downlinks, which could be, very small, could be just ACK. Right? Yeah, so no. So okay, so that's a good question as to why you need 2, why not just 1 downlink? But I think the idea was that 1 could be that I got yours, and then maybe another information which is not really an ACK. I just said 2 ACKs, I made it up actually. I don't know really why the second ACK you need. You need only 1 ACK. But the second one, 2 downlinks, because that is the only time you can receive. Class A stations can receive only when they are up. Otherwise, we assume that they're sleeping. Okay? So, for example, if I want to send something to you, or to somebody else, let's say, and they're sleeping, I cannot do it. At the access point, the server cannot do it. They will wait until you transmit something. Okay, it could be maybe a null data packet. I don't know whether they have null data packet. Whenever they transmit something, then I can send you 2. Yeah.
So, when you talk about IoT, you're talking about like really low data rate, and I believe the communication is going to be in sync. So, why don't we use slotted LoRa instead of pure LoRa?
Sure. So now you're going. See, thing is, I put these things in the wrong order. This technology. So they use the slotted aloha kind of thing, right? I mean, first of all, 11AH did slots. Not only they did slotted aloha, which is just putting the slots makes it a slotted aloha. Second thing is they did segmented slotted aloha. They put people into segments, right? So those are all new concepts. A slotted aloha is not that new concept, actually. I mean, I agree with you. A slotted aloha was done in 1980s. What is slotted aloha is that aloha means you can just do anytime transmission. So that was the original protocol. By the way, aloha protocol, for some of you who, I mean, I don't know, I'm sure everybody tells you these stories when they teach you this. But aloha was done in University of Hawaii. That was the first radio network in the world. Okay? And the problem was that they could not put wires. I mean, like, why they could not put the wires? If you have been to Hawaii, you know there is hundreds of islands. You cannot put the wire, right? So the only way they could communicate is by wireless. So they said, okay, why do make it complicated? Just be simple rule. Whenever you want to transmit, just transmit. Done. That is Aloha protocol. Okay? Aloha is hello in Hawaiian. So basically, that's the protocol. You can say hello anytime you want. And there's no other rule. So that was Aloha. Then people said, it's 18%, so it's not very good. So then they changed it to a slotted Aloha. Not they. Somebody else probably came up with the idea of slotted Aloha, which says that, okay, so we don't do it anytime you want. We will have time windows. So everybody's clock is synchronized, and there are time windows. And so then you speak in a slot. If if you don't do that, then go to the next slot and not in between anywhere. That improves it to, I think, 1 upon E, just from memory. I don't know exactly. It improves a factor of 2. Okay? And on and on. And so hundreds of papers on this whole CSMA series still coming on, 30 years later. But so point is good. But these guys, for class A, this is simple. Basically, you wake up, send it, multiple gateways. See, here what protects them is that there are multiple gateways. You might collide. Let's say if I and her speaks together, maybe I will collide here, but not collide there. Or maybe she will not collide there. Maybe they will both get through. See? So anyway, class B stations, they do class A plus. They have a scheduled time like a RA. Like the restricted access window. So when the beacon comes in, at the beacon, they can get a reserved time and they can send it at that time. So this is people who have more to send. And class C are even more powerful stations, which have some electrical power and they don't go to sleep too much and they can receive any time. You can just send them whenever you want. Okay? All right. So people, class A, mostly sleeping. Class B, kind of, sleeping at a scheduled point. Okay? And class C, almost always awake. Frequency. Frequency means frequency of the band. Again, it is 900 megahertz. Okay? And in the US, when you use 900, this actually applies to both 11AH and this LoRaWAN. But when in the US, there's a power limit. You cannot speak louder than this, but no duty cycle limit. And I will explain what is duty cycle. In Europe, power limit is, I think, kind of very high, but there's a duty cycle limit. Duty cycle means you cannot speak more than 1% of the time. Okay? Keep quiet. You speak too much, kind of thing, so they will say. And so as long as you keep 1%, which means 100 people can speak. After that, 1%, the thing will become congested. And here, what saves in the United States is that your power is low. So if you speak here, maybe other people can speak over there, maybe other people speak here. But somebody can just occupy this area forever. So each has advantages and disadvantages, but they came up with this. Anyway, in Europe, the frequency is different. In Asia, the frequency is even different. And so basically, when you get a LoRaWAN, you have to select the right one. All right, when you go to Amazon, and I went to Amazon, you may find that most of this stuff that is being sold is European. Okay? Legally, you should not be using that in the United States, but who is monitoring? Right? Nobody is monitoring until somebody goes and complains that my neighbor is, is doing it, and then they will come after you. Okay? So look for 915 megahertz.
Is the 433 megahertz band available in the United States?
No. I don't know actually. I will have to check. See, the thing is, at some point I had put the ISM band at different places, but that slide is not in front of me, so from memory I don't know.
I think it is. I think I looked it up here.
Okay. Okay, so if it is, then you know better than I do. Yeah, so basically 433. So the thing is, 915 is where most of the activity right now is. See, what happens is, I will tell you what are the disadvantages of 433. 433 will go even farther, but then the bandwidth would be even narrower. Okay, so if they give you, I don't know how many megahertz they're giving you at 900, 433, they will give you half of that band. You can have two channels, one channel. So if given between the two, they selected 915 for the US, and wherever 915 is not there, then they go for 433. Actually, it says in Asia, but I think that's slightly incorrect, because I think if you go to different countries, Korea, China, India, they might have different number there. Not all of them are at 433. Okay, Japan. So I think they just put Asia together, but I think, if I remember correctly, Japan was at, here is the thing, let me see, where was the number? Okay, here, let me just go back to this slide. Right here. You see, China has this 700, this 800. I don't know where 433 is. Maybe 433 is not shown in this picture. But every country has a different, slightly different band. So to put whole Asia into one block, there's no Asian Radio Regulatory Authority. So they don't work together. I mean, like China and India don't work together on setting up a bandwidth, right? Everybody goes to UNO. So there is a United Nations, basically radio authority, which says, okay, everybody please free up 900 megahertz, and then everybody will free up 900 megahertz. So that's the only thing we have. And what they have done is, because they could not make everybody change, they have divided the world into regions. So region 1, I forget, maybe United States, region 2 is Europe, region 3 is Asia, and so on and so forth, right? So that is what is happening is, yeah. So the regions may decide together in some sense. All right. Back to frequency, right? Same techniques can be used in 2.4 and 5.8. So they're not saying that you cannot use the same technique. And I haven't shown you the technique, and that is the thing which is coming up in a few slides. But you can use the same technique at other frequencies. Of course, you will not reach that far, and you will not be that clean, and so on and so forth. Now, there is still one problem with LoRaWAN. LoRaWAN has not thought about how to do multiple networks in the same area. So if you have a network, if you start experimenting with it, I can't use it, because basically you will be in a mile and I will be in a mile. We'll be just killing each other without knowing each other, right? So this is good only for public networks, they call it, government owned. So the city of St. Louis can put a LoRaWAN, and then that's it, their network. That's how I saw this in Dubai, right? The city of Dubai had put this thing, LoRaWAN. So right now it is for public single deployment in an area. All gateways report to the same server. Any devices can talk to any gateway, but all the devices use the same frequencies. Okay. All right. So what is the secret? Secret is the Chirp spread spectrum. Okay. This slide actually was there in a previous lecture. You had asked me about Chirp. I think it was in 60 gigahertz, someplace we had it. I had removed it at that time. But anyway, you had asked me a question. I said, no, I removed it. So Chirp, I'm bringing it back because now for this lecture, I need it. So we talked about spread spectrum techniques, DSRC, and then, we had the coding, and then we had other one, right? Frequency hopping. Now, this is another one. This is actually not frequency hopping, but it is a signal with continuously increasing or decreasing frequency. So when you send something, you start at frequency 1, and then you keep increasing frequency. So here it is shown in the time domain. This is low frequency, and then becoming higher and higher and higher and higher frequency. And this sounds like birds chirp, or whales chirp in this case. Chirp. Okay? The frequency keeps going up. Or keep going down. And therefore the power becomes spread over an area. And then basically that has certain properties which we will not go in here, but that makes it resistant to noise. And with this Chirp spread spectrum, you can get farther than without it. Okay? Now, so Chirp is old. LoRa modulation is the new name, which is a version of Chirp. And this is patented and proprietary. So the LoRa modulation, actually, the new thing is that the rate of increase and decrease is your code. So I can ask you to go at 1/4 rate, ask you to go at 1/8 rate, and then so you are going at 1/4 and he is going at 1/8. They are two different people. They can transmit at the same time. And by rate increase, I can figure out who is speaking. Understand? So the code is the rate of rise. Here, red and blue. These are two different users. And that's the LoRa modulation. LoRa modulation is that the code is not used to make chips out of the bits. If your code is 4, your rate is 4. Your code is 7, your rate is 7. Things like that, right? Rather than making bits, they change the rate. And so now what it does is it keeps all the good stuff of the Chirp spread spectrum, but also allows you to do multiple transmission, multiple parallel transmissions. And you can receive 19 dB below the noise floor. So if nobody speaks here, there is some noise, radio noise. 19 dB below, if I speak with this LoRa modulation, the total would be 19 dB below the noise. So basically nobody will see any effect.
That's a huge number.
Huh?
I mean, it's a huge number. It's really great. They can listen signals with 19.5 dB below noise.
Yeah, that's something below noise. That's the key. 19.5 dB below noise. So 20 dB is like 100, right? 100 is 20 dB. 1/100th of the noise level. All right? And of course, that's why it is patented and the patent has not been given up, right? So here's the thing. Anybody who makes LoRa product, which they can make, they have to buy the chip from Semtech. And it is so good that people are doing it. I mean, I was really surprised that how could Cisco and IBM and everybody join the LoRa Alliance and promote it. Cisco very heavily promoted that LoRaWAN in that meeting, right? Why are they promoting it? Because that chip is patented, but everything else they can invent on the top of it. So power level is determined adaptively based upon the data rate and link condition. So basically, so somebody is given high rise rate, because then they can finish the transmission in very short time and go to sleep. If then somebody is given low rate, and so the thing is, the rates, etc., depend upon the rise rate, and the time depends upon the rise rates. Everything is adaptively done. Yeah.
Is this a modulation scheme that could be used to improve other existing PHYs in different?
Of course. So what will happen is, the only hindrance in its adoption is that it is proprietary. If it becomes a little bit more public, or even if it is proprietary, maybe the terms are very, very reasonable, then other standards, future standards will take it. So the way it works is that if you don't follow the current knowledge, then you're not doing the job, right? So everybody in the new standards will take everything new, what is coming from here. So here it is basically the PHY innovation. Right? Why we could not transmit a mile using Wi-Fi before, or something like that. So this is, by the way, all the low power WANs, they are competing with cellular phones, cellular traffic, cellular technology, which we are going to talk next, right? So if this was not there, then our only choice to talk a mile away is cell phone, right? Which is not very energy efficient. Right? I mean, you cannot charge your meter every day. I mean, probably your electric meter you can charge because it's connected to electrical power. But your gas meter and everything else, you're not going to charge every day, even if it has a battery or, something like that. So cellular industry is competing to get that IoT market, but the other people are also competing to get the same IoT market. Right? And this is what is going on right now in the industry is IoT. Okay, yeah.
You just talked about the advantages of this LoRaWAN. What are the disadvantages? I mean, it should be like a trade-off. So
okay, so I think that we already talked about this one. I can tell you two at least. One is that single deployment is not good. Right? They have to work that out, right? Single deployment, so that multiple. I mean, right now it has to be owned by the city, not by electrical company. So electrical company and water company cannot have their own network, right? Everybody has to report to one network. Second thing is that I am surprised when I looked at the LoRa Alliance, I was surprised that the PHY is still proprietary, which limits. I mean, that's not a technical advantage, but disadvantage, but business disadvantage. Okay. All right. That actually all I wanted to say. Let me see. There's one more slide. Okay. So this is LoRa modulation. LoRaWAN. So the word LoRa, actually, when you say just LoRa Alliance, LoRa really refers to the physical layer, and the LoRaWAN refers to the MAC layer. Now, MAC layer is public. This is interesting. So while the PHY layer is patented and so on and so forth we talked about, the MAC layer is public, so it is designed by IBM and Cisco, and everybody sitting into a room and deciding what to do. So this is more of a public thing, but this is the MAC function. And we talked about the server and the server. So this is another thing which has happened. So some of you know about the software-defined networking, SDN. All right, those of you who took the recent advances in networking last semester know it much better. But basically, what SDN is saying is that we should manage the whole network from one place. Okay. Right now, the network is designed so that every device is independent and distributed, makes its own routes, and does whatever it thinks is the optimal thing to do, which was good in 1968 when the internet was invented, but it's not good when somebody owns the network of 16,000 devices, and every device is making its own decision. Right? So they're centralizing the power into a central controller. That's what SDN is about. Is from one place you can program the whole network. Same concept here. The server is the central control, and all the gateways everywhere they can be, but basically one brain, and that does everything, right? So this is another centralized kind of thing. This is one server. That's it, and you can have many gateways, many devices. The server manages the network and runs the MAC. So this is, I don't know. I mean, I'm just guessing that this concept might have come from SDN, although they don't even use the word SDN anywhere in the description. but this kind of thing would not have passed 5 years ago. Everybody would just, no, 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 we can't have a single server, we can't have this and that. Now nobody says no to those things. So there is this thing. It eliminates duplicate receptions, so now you get multiple copies, and this is the one that deduplicates them. It schedules the acknowledgement and adopts the data rate. It makes all the decisions sitting right there. Okay, so I mean, unlike a distributed protocol before, where we used to have the rules for protocols, here everything is in that server. Yeah.
It's confusing to me why that seems to be more popular now. So I feel like it would be working in like the other way.
Oh, that's a whole decision. You'll have to take another course now. I mean, so the thing is, I would not have sold, be able to sell this 5 years ago, centralized control. But today in 2016, centralized control is the thing.
Why is that getting more popular?
Because, okay, that was your original question. So I mean, basically, it is much more manageable. Let me give you an example. Every company runs in a centralized manner. No company runs in a distributed manner. So let's say if we make, this is a company, and we make that, okay, you can decide your own rule, you can decide your own rule. So, okay, so you are doing on something, and then, you get sick. Then you tell all the neighbors that I'm sick, and they tell their neighbors that, okay, Steven is sick today, and so on and so forth. It will take quite some time for people to know. On the other hand, you just tell your manager, I'm sick, and then manager takes care of you. When you are back, the manager takes care of you. So thing is, things move faster, and that's how the real world works.
What happens when the manager gets sick, though?
Yes, manager gets sick, there is another manager. He tells his manager's manager, and the manager's manager tells the other managers that, look, Raj is sick or whatever. I'm just saying that basically, the whole thing works as a tree. Nothing works as a distributed thing in the real world, right?
So they're like backup servers?
Yeah, of course.
Okay.
Yeah, of course. All right. So this is, servers also determine the data rate. So I mean, everything is done automatically inside the box, and you can change that program depending upon your need. So there is, as opposed to, setting up one rule for everybody. Now this is a new trend, right? That brings us to the end of LoRaWAN. Summary is that it is the new MAC standard. LoRaWAN by itself, the name is the MAC standard by the LoRa Alliance. LoRa modulation is the modulation scheme, the Chirp spread spectrum, variation of Chirp spread spectrum, where the rate of frequency increases or decreases is modulated by the symbol. Symbol means you take a group of bits, that becomes a symbol, and the symbol determines, what is your rate. Increases its resistance to noise, allows multiple parallel transmission, those are the two good things, and centralized management and media access control using a server, and devices broadcast to all gateways, and the best gateway replies back. So you don't have to worry about who is listening, you just transmit and multiple people will listen, and you'll get the response from the one. All right, these are some of the new things in this one. That brings us to this module on LPWAN, low power WAN. There is much more. I could keep talking for the whole semester on IoT. Okay, and I was going to do at least one more lecture, which I'm not going to do now. So this is the last lecture on IoT. LoRaWAN has already been implemented and is the leading candidate. 11AH is a new standard to be productized. So there are no products yet. I mean, like, there might be some chips here and there, but it's not something that you can buy easily. Whereas LoRaWAN is something that I have seen working, and people are buying and using it. So, and you guys can just do the reading list as usual.